Hi, welcome to my video on metamorphic rocks. In this, we're going to discuss what a metamorphic rock is, how it's formed, and show you a few examples of some metamorphic rocks that I have here. So, what rocks can form a metamorphic rock? Well, if you remember the rock cycle, any type of other rock can form a metamorphic. So, sedimentary, igneous, or another metamorphic rock itself. Any of those can form a metamorphic rock. So what about the processes that can create a metamorphic rock? Well, you have contact metamorphism, which is when you have magma that comes up and intrudes upon the parent rock of your metamorphic. So you have heat, lots of it, and that can actually change the structure into metamorphosing the parent rock into the current metamorphic. You also have regional metamorphism, which is pressure or stress. So it squeezes the rock and realigns the minerals. And the third type of process that can create a metamorphic rock is hydrothermal metamorphism. And that is when chemically active fluids come and they realign the crystals, or they make the crystals easier to grow and make a more hospitable environment. And then it changes how those crystals appear. So, some key concepts for metamorphic rocks. First of all, metamorphic rocks go from low all the way up to high-grade metamorphism. This is very important to remember, everything in between. And all metamorphic rocks have a parent rock, so they have something that they come from. So if you see this on a test, what is the parent rock of this rock? You know that you're looking at a metamorphic, because only metamorphics have parent rocks. Now, metamorphic rock textures. Very important here. You've got foliated and non-foliated. Now, your foliated rocks is a distinctive arrangement of minerals within that rock. So, going from low to high-grade metamorphism, you have a slaty appearance, which, of course, is like slate. So, basically what you're looking at right here. And then you go from slaty to schistose, which is where you find the minerals being a little bit better aligned, but not quite, to an orderly alignment, which would actually be gneissic, which is this right here, where you can see the minerals have aligned themselves in a more orderly fashion. So, slaty, low-grade metamorphism. Schistose, a little bit higher grade of metamorphism. You can actually see the shine from the mica that's in there. And then finally, you have your gneissic texture, which is high-grade metamorphism. And you also have non-foliated rocks, which include marble, which there are no orderly ways for those to recrystallize. But the neat thing about marble is that because it comes from limestone, so limestone's its parent rock, you can actually have it where if you can powder it, you can have it fizz with hydrochloric acid. So that's very useful. And it's also useful to determine whether or not you're looking at a marble or a quartzite. So marble comes from limestone and will fizz. Quartzite comes from quartz and will not fizz. So, pretty easy trend. Now, trends in metamorphic rocks. Start with, in this case, we're starting with a sedimentary rock. So we have shale. So it's, well, shaly. You have little flakes of it. It gets off when you're, walking around out, and it ends up in your socks if you're hiking. We all know what shale is. Shale sedimentary. So, this is the parent rock. And then you go up one grade of metamorphism to slate, which has this really nice conchoidal fracture right here, if you can see it. That's kind of a key component for slate, is that conchoidal kind of scooped out look for the fracture. Then, next grade up is phyllite, where you have this really nice sheen, and it's kind of silky looking. So, phyllite, and then schist, where the minerals are a little bit more orderly arranged. You can kind of see it over here on the side. And then finally, gneissic, where you actually see a more definitive banding of the crystals, and they're a little bit, well, not a little bit, they're a lot more well defined. And this structure actually, I know you have probably come across, it is a boudinage structure from the French word for sausage, so kind of looks like little sausages in there. But hopefully this helped, and I look forward to seeing you again. Thanks.